This video is going to be looking at trial and improvement. Now, trial and improvement involves substituting the unknown with different values until we find one that works. So if we're given a solution to solve, we try different numbers, improving every time until we get a solution that works. We can use this method if we are asked to solve an equation where there is no exact answer, or if you're asked to give your solution to a given number of decimal places. So when I'm tackling these sorts of questions, I do it with a table. So I'm going to have three columns. First is x. Now x are the numbers I'm going to try. The second is the function of x. So this basically is the equation I want to solve. And then the third column is the comment. Okay, so trial and improvement, I set up three-column table. X, function of x, and the comment. So let's have a look at an example. So this question says, use a method of trial and improvement to find x to one decimal place such that x squared minus 3x equals 6, where x is between 4 and 5. Okay, so I'm going to set up my table. I need three columns to my table. The first is x. The second is the function of x. Now that means the equation I want to solve. So from the question, the equation I want to solve is x squared minus 3x equals 6. So x squared minus 3x is my function. Okay, so in here I want x squared minus 3x. And I want this to equal 6. And the final column is comment. Okay, so from the question, it says I want to find x to one decimal place and x is between 4 and 5. So I'm going to start with a number that's bang in the middle of 4 and 5. So I'm going to choose 4.5. So I use 4.5 as my starting value of x. So I'm going to put 4.5 into my equation, into my function. So x squared minus 3x becomes 4.5 squared, take away 3 times 4.5, which gives me an answer, type that in my calculator, of 6.75. Okay, so 6.75 is the answer that 4.5 into the function would give me. I'm after 6. So my comment is that this number is too high. If my comment is too high, then I need to try a number that's less than this. So I'm going to try 4.4. Again, I'm going to sub 4.4 into my equation. So that's 4.4 squared, take away 3 multiplied by 4.4. And that gives me an answer of 6.16. Again, I'm after 6. My answer is 6.16, so that's too high. So I'm going to choose a smaller number again. So see, I'm trialing and then I'm improving on my answer. So 4.3, sub that into my calculator, 4.3 squared, take away 3 lots of 4.3, gives me an answer of 5.59. Now we can notice that we've jumped below 6. So my comment is that it's too low. This is low. Okay, so 4.4 is too high and 4.3 is too low. So I know that my value of x to one decimal place is going to lie between 4.4 and 4.3. So let's draw a number line of that. Okay, so if I have 4.3 here, 4.4, this is too low and this is too high. So I know that my value of x, my true value of x, is going to lie somewhere in between here. So to one decimal place, it's either going to be 4.3 or 4.4. So to decide which one, I am going to choose the halfway mark. Okay, so I'm going to choose the halfway mark and sub that into my equation. So halfway between 4.3 and 4.4 is 4.35. So that's what I'm going to choose for x. So put it into my table, 4.35. 4.35 squared, take away 3 times 4.35 gives me an answer of 5.8725. My comment, well, 5.8725 is lower than 6, so this is too low. Okay, back to my number line. 4.35 is too low. So I can now tell from this that the true value of x must lie somewhere in this region, because 4.35 is too low and 4.4 is too high. So because I want my answer to 1 decimal place, I know that the true value of x lies somewhere in there, so I would round up to 4.4 to 1 decimal place. So therefore, x equals 4.4 to 1 decimal place.